Hi everyone, welcome to this lesson which is called Length of a Line Segment. So let's say that you have a bunch of line segments, as I have in this picture. I have three line segments, AB, this one, CD, and KL. Pause the video for a second and see if you can figure out how long each of the line segments are. Pause the video now. Okay, so if you look at AB, the one in red, you can count the squares, right? You can start at A, for example, and just count the squares, count over, and you would get that there are 6 squares between A and B, so it's 6 units long. CD, you could do the same thing, and again, start at C and count down, and then you would find there are 8 squares for that one. Now for KL, this one's a little hard because you can't just count down the line like this because it's not entirely clear where one unit is. Right? Do I go like, if I, for example, zoom in, like, is that one or is that one? Like, it's not really clear. It's because we're on an angle in this case. So, whereas if the line is straight, either horizontal or vertical, I can count the length pretty easily. If it's on a diagonal, it's not so simple. Okay, so before we figure out how to solve that, I want you to remember the Pythagorean Theorem. Here it is, written out, and this is, how you might read it in a math textbook. For any right triangle, the sum of the hypotenuse is the sum of the squares of the legs. So just in case you've forgotten, if this is a triangle, and it has to be a right triangle, meaning there's a right angle in it, the hypotenuse is always the longest side. So this side here is the hypotenuse. The two shorter sides are known as the legs. Okay? Now, a lot of people don't normally remember it in this form. Like if I were to ask them what the Pythagorean theorem is, they would probably write it down as the formula a squared plus b squared equals c squared, where a is one of the legs, b is the other leg, and c is the hypotenuse. So usually when you think of the Pythagorean theorem, you actually just think of the formula. But there is actually a little bit more to it than that. Okay, so now we come to this distance formula. And although the distance formula may look quite a bit different than the Pythagorean theorem, I assure you that they are connected. But for now, I just want to show you how the formula works. So the idea is that if we have any 2 points, we can figure out the distance between them, or another way of thinking about it is if we connect those 2 points to make a line segment, we can find the length of the line segment. Now what we're going to do in this case is we're going to take our points, our endpoints, and we're going to write them in a table of values. We've been doing this in class for a couple days. And we're going to work out the change in x and the change in y, and then we're going to take those two numbers, the change in x and the change in y, and put it into the formula. Okay, now I just want to, before I show you how this works in a couple examples, I want to show you where this comes from. So if I just draw my triangle again, I'll draw it this way. So let's say that those 2 points that I've drawn are the end points. Now, if I go from this end point down, then I have gone some distance in y. I've gone down some distance in y. And then from that point here, if I go across to the other end point, I will have gone some distance in x. Okay? So the distance that I've actually gone is this distance. That's the distance that I want to find. And if you look at this, and if you draw that as a right angle, you can see that now I have a right angle triangle, and this distance, which I'm calling d now, I'm just changing the letter, it's still the good old hypotenuse from a right angle triangle before. Okay, it's the exact same thing. So before, where I had a squared and b squared and c squared, now I have delta y squared, delta x squared, and d squared. And so in order to get d, so let me just write that down. So I have d squared equals delta x squared plus delta y squared. Now since I want a distance, I don't want a distance squared. I don't want the distance squared, I will just want the distance. I have to undo that squaring or square root both sides. So if I square root the left side, I just get d, and then I have to apply the square root to the other side as well. Just like so. Okay, just like that. So that's where it comes from. It actually does come from, the distance formula does come from the Pythagorean theorem. Okay, let's do a few examples. So here I'm basically just going to go straight into using the distance formula given a series of, or given a pair of endpoints. So in this case, I'm going to start off with my table of values, x and y. I write in my points, -6, 5, and 4, 7. Okay? So in the x, I'm going to be adding 10. Sorry. This doesn't quite work. Okay, plus 10. And then in the y, I'm going to be adding 2. So this number is my delta x, and this number is my delta y. So going from the formula, d equals the square root of delta x squared plus delta y squared. I'm going to put in my numbers. Delta x is 10. So I have 10 squared plus 2 squared. And then, just redo that a little bit there. Okay. D equals the square root of 10 squared is 100 plus 4, and d equals the square root of 104. Now, you have two options when you get to this point. You can just leave it like this. So this is correct, the square root of 104. There's nothing wrong with that. Or you can take out your calculator and work out what the square root of 104 is. It's a little more than 10, like 10.1 or something. Either one is okay. But if you do use your calculator and punch it in there, then you have to be sure to say d is approximately equal to 10.2. I just worked it out there. Okay, so that little approximation sign has to be there because it's no longer exactly equal to 10.2. All right, that was the first example. Let's do the second example, number B, letter B. Again, I'm going to start off with my table of values, x and y, put in my points, 10, -3, 2, -8. So from here to here, I'm subtracting 8. From here to here, I am subtracting 5. Okay. Now, in the distance formula, put that in. One thing to note is because our change in x is negative, that doesn't matter because we're squaring it. So we're going to go -8 and square it. So when I square -8, I still get back a positive number. Same thing with -5. I'm going to do that there. Okay, and then so d equals the square root. -8 squared is positive 64. -5 squared is positive 25. And again, d is the square root of 89. Okay, so again, if you want, you can just stop there, square root 89, and just leave it alone. Or you can pull out your calculator, and you can approximate the answer. D is approximately equal to 9.4. Okay, so usually we just go to one decimal place. That's fine for our purposes. We don't have to go crazy. All right, so that's it. That's how. So in this case, we have these two examples. The length of the line segment between these points was 10.2 units, and the length of the line segment between these points was 9.4 units. Okay, last example. How far is the point 5, -4 from the intersection of y equals 2x minus 7 and y equals -3x plus 8? Okay, so in this case, we're going back to our last unit, which involved intersection of lines. So we need to find the intersection between this line and this line. And hopefully by now you realize that the easiest way to do this is by comparison. So 2x minus 7 equals negative 3x plus 8. All right, we're going to do this. And so on the right side, my x's are canceled. On the left side, I have 5x. I'm going to add 7 to both sides. And so I'll have 5x equals 15. So then divide out, and I get x equals 3. Okay, x equals 3. And then I substitute that back into this equation up here. So I'm going to say y equals 2 times 3 minus 7, which is negative 1. So the POI is 3, negative 1. Okay, from this point, we just need to put this new point and the other point that was given in the question, this one, 5, negative 4, into a table of values. Okay, so we have 5, negative 4, and 3, negative 1. Here our delta x is negative 2. Here our delta y is positive 3. Okay, and just put that into our distance formula. Delta x squared plus delta y squared. And we get negative 2 squared plus 3 squared. And that's simply the square root of 13. And again, if you had a mind to do so, you could write that as d is approximately equal to 3.6. Okay, so that's the distance. That's how far it is from this random point to the intersection of these two lines. Okay, that's it for this video. See you in class.